In order to verify that this function has 2 plus or minus I as its zeros, there's a couple of ways to do it. One is take each number, for example 2 plus I, substitute in for x, do all of the algebra, and show that you get the answer 0. We would then need to repeat with 2 minus I and show that we get the answer 0. Or we can set it equal to 0 and use the quadratic formula, and then we would only need to do that once and we would get the two answers 2 plus or minus I. So it's going to be the quadratic formula is equal to negative b plus or minus the square root b squared minus 4 times a times c. And then the whole thing is divided by 2 times a. Working inside of the radical, we've got a 16, and then 3 negatives is going to mean subtract. 16 subtract a 4 times 1 times 5, so subtract 20. And then it's all divided by negative 2. So now in the radical, we've got the square root of a negative 4, and that can be simplified. So we've got negative 4 plus or minus the square root of a negative 4 is 2i, and then divide by negative 2. Now all of these can be divided by 2, so we're going to end up with, well, a negative into a negative is going to make positive 2, and then this says switch the signs, but the plus minus means you're already considering both signs, so we still have the positive and negative cases, and then the 2's cancel, and sure enough, this was correct. It says find any x-intercepts for the function. Well, these two roots are the only two roots or zeros that this function can have. The most number of roots it can have is 2, and it already has these two, so we should not see any x-intercepts when we take a look at the graph. So graph the original function, negative x squared plus a 4x minus a 5. Zoom standard, and we should see a parabola that does not hit the x-axis. It comes close, but does not hit the x-axis. So there are no x-intercepts.